Self-exercise 2.2, questions number 1. Find dy dx by using first principle for each of the following functions y equal to f of x. Questions A, y equal to x. So always refer to this as your guidance when doing the first principle. So using this graph as an example, when the coordinate x has a small changes of delta x, then the coordinate x will become x plus delta x. The small change in x will also resulting in the small change in the y. Then the coordinate y will become y plus delta y. So for question A, when the coordinate y here become y plus delta y, then the coordinate x will become x plus delta x. Next, move the y to the right hand side. It will become x plus delta x minus y. So here we can replace the y with the x as y is equal to x. So here x minus x will be cancelled. So delta y is equal to delta x. So what we are doing so far is for this part. For questions A, I can also write y equal to x as f of x is equal to x. So delta y is equal to f of x plus delta x minus f of x. So when the input is x plus delta x, then the x here will change to x plus delta x as well. Then minus fx, which is the x. So to do this faster, you can always start with this step. So this is the same as the step before. So next, we're going to divide both sides with delta x. Simplify this, the answer will be 1. So this is dy dx. So here delta y, delta x here is equal to 1. So here there is no delta x for us to replace it with 0. Then dy dx is just equal to 1. Questions B, y equal to 5x. So this is the same as f of x is equal to 5x. So first we're going to start with this. So for the input x plus delta x, so the x here we're going to replace it with x plus delta x. It will be 5 bracket x plus delta x, then minus fx, which is 5x. Next, expand this, we're going to get 5x plus 5 delta x minus 5x. So 5x minus 5x will be cancelled. Then delta y is equal to 5 delta x. Next, we're going to divide both sides with delta x. So delta x here will be cancelled. This is equal to 5. So here, the delta y, delta x, we're going to replace it with 5. So here, there is no delta x for us to replace it with 0. Then the answer for the dy dx will be just equal to 5. Question C, y equal to negative 4x. This is the same as f of x equal to negative 4x. So here we're going to substitute the x here with x plus delta x. So negative 4 bracket x plus delta x minus the fx, which is negative 4x. Expand this, it will be negative 4x minus 4 delta x plus 4x. So negative 4x plus 4x will be cancelled. Then delta y is equal to negative 4 delta x. Next, divide both sides with delta x. So delta x here will be cancelled. This is equal to negative 4. To find dy dx, we're going to substitute the delta y, delta x here with negative 4. Again, there is no delta x for us to replace it with 0. Then the answer for the dy dx here will just be equal to negative 4. Questions D, y equal to 6x squared. So here I can write this as f of x equal to 6x squared. So first we're going to substitute the x here with x plus delta x. This will be 6 brackets x plus delta x squared minus f of x, which is 6x squared. Next, we're going to expand this. It will be 6 brackets x squared plus 2x delta x plus delta x squared minus 6x squared. Then continue expand this 6x squared plus 12x delta x plus 6 delta x squared minus 6x squared. So 6x squared minus 6x squared will be cancelled. Then this will be the delta y. Next, divide both sides with delta x. So delta x here will be cancelled and this just left with 1. This is equal to 12x plus 6 delta x. Next, to find dy dx, replace the delta y delta x here with this. As delta x approach 0, then we're going to substitute the delta x here with 0. Then dy dx is equal to 12x. Questions E. Y equal to negative x squared. So here I can also write this as f of x equal to negative x squared. So first, substitute the x here with x plus delta x. Negative bracket x plus delta x squared minus f of x, which is negative x squared. Expand this. Negative bracket x squared plus 2x delta x plus delta x squared plus x squared. Get the thing out of the bracket, so negative x squared minus 2x delta x minus delta x squared plus x squared. So negative x squared plus x squared will be cancelled. Next, divide both sides with delta x. So delta x here will be cancelled and this just left with power 1. This is equal to negative 2x minus delta x. To find dy dx, replace the delta y delta x here with this. As delta x approach 0, then we're going to substitute the delta x here with 0. Then dy dx is equal to negative 2x. Question F. Y equal to 2x cubed. So first I can write this as f of x equal to 2x cubed. So next I'm going to substitute the x here with x plus delta x. So 2 bracket x plus delta x cubed minus f of x, which is 2x cubed. So next we're going to expand this. So here to expand the x plus delta x cubed, I can write it as x plus delta x times x plus delta x squared. So first I am to expand this. This is 2x plus 2 delta x. Then I also going to expand it. So this will be x squared plus 2x delta x plus delta x squared minus 2x cubed. Next, we're going to continue to expand this by following the arrow. So 2x times x squared, we're going to get 2x cubed plus 4x squared delta x plus 2x delta x squared, followed by 2x squared delta x plus 4x delta x squared plus 2 delta x cubed minus 2x cubed. So here 2x cubed minus 2x cubed will be cancelled. Next, we're going to sum the like terms. Here we're going to get 6x squared delta x. Another like term will be these two. Here we're going to get 6x delta x squared plus 2 delta x cubed. So after this, we're going to divide both sides with delta x. So here delta x will be cancelled, so just left with 1, and this one will left with 2. So delta y delta x, this is equal to 6x squared plus 6x delta x plus 2 delta x squared. To find dy dx, we're going to substitute the delta y delta x here with this. As delta x approach 0, so the delta x here we're going to replace it with 0. So dy dx is equal to 6x squared. Question G, y equal to 1 over 2 x squared. So I can write this as f of x equal to 1 over 2 x squared as well. So next, I'm going to substitute the x here with x plus delta x. So it will be 1 over 2 bracket x plus delta x squared minus the f of x, which is 1 over 2 x squared. Next, I'm going to expand this. So this is equal to 1 over 2 bracket x squared plus 2x delta x plus delta x squared minus 1 over 2 x squared. Expand this, you're going to get 1 over 2 x squared plus x delta x plus 1 over 2 delta x squared minus 1 over 2 x squared. So 1 over 2 x squared minus 1 over 2 x squared will be cancelled. So delta y is equal to x delta x plus 1 over 2 delta x squared. So next, we're going to divide both sides with delta x. So delta x here will be cancelled. So this one just left with 1. So this is equal to x plus 1 over 2 delta x. To find dy dx, we're going to substitute the delta y over delta x with this. As delta x approach 0, then we're going to substitute the delta x here with 0. Then dy dx is equal to x. Question H, y equal to 1 over x. So this is the same as f of x equal to 1 over x. So next, I'm going to substitute the x here with x plus delta x. 1 over x plus delta x, then minus the f of x, which is 1 over x. To solve this, I will need to equalize the denominator. So this is equal to x minus delta x over x times x plus delta x. So x minus x here will be cancelled. So next, I'm going to divide both sides with delta x. So divide by delta x is also the same meaning as multiply by 1 over delta x. So the delta x here can be cancelled. This is equal to negative 1 over x plus delta x. To find dy dx, substitute the delta y, delta x with this. As delta x approach 0, then we're going to substitute the delta x here with 0. So this is equal to negative 1 over x squared. Question number 2. Given y equal to 2x squared minus x plus 7, find dy dx by using first principles. So here I'm going to assume that y is equal to f of x. So first, I'm going to substitute x plus delta x into the x here. So this is equal to 2 bracket x plus delta x squared minus x plus delta x plus 7. Then we're going to minus the f of x, which is going to be 2x squared minus x plus 7. So next, I'm going to expand this. So 2 brackets x squared plus 2x delta x plus delta x squared. Then minus x minus delta x plus 7 minus 2x squared plus x minus 7. Continue with the expansions. You're going to get 2x squared plus 4x delta x plus 2 delta x squared. So negative x plus x here will be cancelled. The same with 7 minus 7. Then just left with negative delta x minus 2x squared. So next 2x squared minus 2x squared will be cancelled as well. So this will be the delta y. So next I'm going to divide both sides with delta x. So here delta x will be cancelled. So this one just left with 1. This is equal to 4x plus 2 delta x minus 1. To find the dy dx, substitute this with this one. As delta x approaches 0, so we're going to substitute the delta x here with 0. Then dy dx is equal to 4x minus 1. Questions number 3. By using first principle, finds the gradient functions to the curve y equal to 3 plus x minus x squared. Remember, the gradient functions is referred to the dy dx. So here let us assume that y is equal to f of x. So first we're going to substitute x plus delta x into the x here. So 3 plus bracket x plus delta x minus x plus delta x squared. Then we're going to minus with the f of x, which is the y, minus bracket 3 plus x minus x squared. So here we're going to expand this. So bracket x squared plus 2x delta x plus delta x squared minus 3 minus x plus x squared. So here 3 minus 3 will be cancelled. X minus x will be cancelled as well. So next we're going to get delta x minus x squared minus 2x delta x minus delta x squared plus x squared. So negative x squared plus x squared here will be cancelled. So this will be the delta y. So next we're going to divide both sides with the delta x. So here this will be cancelled and this one will left with 1. This will equal to 1 minus 2x minus delta x. To find dy dx, substitute the delta y delta x with this. As delta x approach 0, so we're going to substitute the delta x here with 0. Then dy dx is equal to 1 minus 2x.